Good morning. It's August 1st, and this is your daily brief in science. Here's everything you need to know. A new report has emerged, revealing that nearly half of dementia cases could be prevented or delayed by addressing 14 identified risk factors. This highlights the critical need for effective strategies to combat dementia, especially as over 10 million people globally develop the condition each year. While lifestyle changes can significantly modify approximately 45% of dementia risk, experts emphasize that age and genetics remain substantial factors. This duality necessitates action at both individual and societal levels to tackle the growing issue of dementia. Health equity is a pressing concern, as the identified risk factors disproportionately affect socioeconomically disadvantaged populations and low to middle-income countries. The report outlines 13 recommendations for individuals and governments, which include improving access to education, providing hearing aids, and promoting healthy lifestyles. Among the newly recognized risk factors are vision loss and high cholesterol, joining previous findings that include hypertension and social isolation. Addressing hearing and vision loss is vital, as timely treatment can help mitigate risks associated with cognitive decline. Maintaining an active brain and body through regular social engagement and continuous learning has been linked to slower cognitive decline and lower dementia risk. Implementing these prevention measures will require coordinated efforts from individuals, healthcare systems, and policymakers, potentially leading to significant improvements in quality of life and economic savings. Dementia, often caused by diseases like Alzheimer's that damage brain nerve cells, is not an inevitable consequence of aging. However, the global population living with dementia is projected to nearly triple to 153 million by 2050, resulting in health and social costs that could exceed $1 trillion annually. A remarkable discovery in paleontology shines a light on the early evolution of mandibulates, with significant implications for our understanding of arthropods. Researchers have focused on Odoria, one of the earliest known mandibulates, which exhibits evolutionary traits like mandibles that improved feeding efficiency. Fossils from the Burgess Shale, including Odoria, are crucial for insights into the early evolution of both mandibulates and other enigmatic species. In a related finding, Dr. Smith identified a unique fossilized larva named Ut yuanxi after examining it under a microscope in China. This fossil, dating back 520 million years, is remarkable for its nearly intact internal organs, providing a rare glimpse into ancient biology. Advanced three-dimensional preservation techniques have allowed scientists to reveal intricate details of UT's anatomy, including its nervous system configuration. The research on UT, published in the journal Nature, underscores the significance of this ancient specimen in understanding early arthropod evolution. Researchers utilized powerful X-ray scanning to uncover the internal anatomy of the fossil, which has remarkably survived for 500 million years. Lead researcher Dr. Martin Smith expressed amazement at the intricate anatomical features preserved in UT, which contribute to the understanding of evolutionary steps leading to the complex body structures seen in modern arthropods. These findings not only enrich the understanding of arthropod evolution, but also highlight the competitive dynamics during the Cambrian explosion. In a related study, researchers also discovered Nuchichthys rhynchocephalus, a soft-bodied vertebrate, further illuminating the early stages of vertebrate evolution. Astroscale, a Japanese company, is teaming up with the Japan Aerospace Agency, or JAXA, to tackle the pressing issue of space debris. This collaboration is part of JAXA's commercial removal of debris demonstration, known as CRD2, which has made significant strides in its initial phase. A key component of this project is the ADRAS-J mission, launched in February 2024, which focuses on testing advanced debris removal technologies. ADRAS-J has already achieved several milestones, including successful proximity approaches and fixed-point observations of space debris. Notably, on July 15th and 16th, the satellite approached a 36-foot-long piece of rocket debris, coming within approximately 50 meters, confirming its potential for removal. Utilizing ground-based observation data, ADRAS-J demonstrated its ability to navigate within mere meters of the target debris. Astroscale plans to employ a robotic arm on a spacecraft currently under construction to capture this debris and guide it into a trajectory that will allow it to burn up upon re-entry into Earth's atmosphere. This mission is a critical step in addressing the escalating problem of space junk in low Earth orbit, which poses significant risks to operational satellites and the International Space Station. The data collected from these operations will play a vital role in future debris capture and removal strategies, contributing to a more sustainable space environment. Recent incidents involving space debris have highlighted the urgency of these initiatives, as astronauts aboard the ISS were recently required to take shelter due to nearby debris. Additionally, the emergence of megaconstellations, such as OneWeb and Starlink, further stresses the necessity for effective debris removal solutions to mitigate orbital congestion. Astroscale is also working on a specialized satellite service designed to collect space junk, reinforcing its commitment to addressing this critical issue. Nick Shave, managing director of Astroscale UK, has indicated plans for a commercial satellite removal service following the successful demonstration missions. A recent study from the La Jolla Institute for Immunology has unveiled significant findings regarding immune cell memory in the upper airways of adults. Researchers, led by Sidney Ramirez, have identified tissue-resident memory cells that are crucial in defending against respiratory diseases, including SARS-CoV-2. This research underscores the need to understand immune responses in the upper airway, particularly during viral infections. The study reveals that the upper airway houses long-lived immune cells, such as virus-specific memory T cells and memory B cells, which are essential for combating infections and fostering long-term immunity. Notably, participants who had contracted COVID-19 exhibited B cells in their nasal passages that specifically targeted SARS-CoV-2, indicating robust immune responses. The nose acts as a vital entry point for pathogens, with nasal conchae helping to warm and moisten the air before it enters the lungs. Furthermore, the research highlights that adenoids, immune organs situated at the back of the nose, possess active germinal centers capable of producing specialized B cells trained to fight specific viruses, even in older adults. During infections, these adenoids become more engaged, generating germinal center B cells that bolster the immune response. The implications of these findings could lead to advancements in nasal vaccinations and treatments for various conditions, including allergies and autoimmune diseases. To facilitate this research, scientists developed a new swabbing technique that effectively collects immune cells from the nasal passages, addressing previous sampling challenges. Co-author Paul Lopez noted that this innovative technique could also aid in investigating various immune conditions, such as chronic rhinosinusitis. Future research will focus on how immune cell populations in the airway respond to intranasal vaccines and the longevity of memory B and T cells. A recent study has unveiled a unique type of wood in tulip trees that could play a significant role in enhancing carbon sequestration in plantation forests. This research focused on two species, Liriodendron tulipifera, native to North America, and Liriodendron chinense, found in China and Vietnam. Notably, tulip trees diverged from magnolia trees 30 to 50 million years ago, a period marked by a significant drop in atmospheric CO2 levels. Conducted by scientists from Jagiellonian University and the University of Cambridge, the study employed cryoscanning electron microscopy to analyze the wood structure. This research is part of a broader survey examining the evolution of wood ultrastructure across 33 tree species at the Cambridge University Botanic Garden. Understanding the wood structure is crucial for improving carbon capture efforts, as secondary cell walls are major carbon reservoirs. Lead author Dr. Jan Lietzakowski highlighted that the unique macrofibril structure of tulip trees may enhance their effectiveness in carbon storage. Previous studies have shown that liriodendrons are fast-growing and possess high carbon sequestration rates, making them suitable for carbon plantation schemes. The research emphasizes the vital role of botanic gardens in facilitating significant scientific studies by providing a diverse range of plant species for research. The findings were published in the journal New Phytologist, showcasing the relevance of this research conducted during the summer of 2022. A mature tulip tree can absorb over 48 pounds of carbon dioxide annually, and an acre of mature trees can offset CO2 produced by a car driven 26,000 miles. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.